Welcome to the first video on 11.6, events involving not and or, and then we'll talk about odds. So today's focus is going to be involving not, okay? So events involving not. So according to the Harvard Center, the odds in favor of a fatal shark attack are 1 to 280 million, and the odds against a fatal airplane accident are 3 million to 1. We can determine the odds in favor and the odds against such events as these. That's going to be the second part of this video, is talking about odds. For now, we're just really going to focus on finding the probability that an event will not occur. So something we have to familiarize ourselves with is something called a complement. Okay? The event not E is the complement of E, because it is the set of all outcomes in the sample space S that are not outcomes in the event E. So the sum of the probability that an event will occur and the probability that an event will not occur is 1, which makes sense, okay? So the probability of something happening plus the probability of it not happening is going to be 1. So we're going to keep that in mind. So we can kind of play around with this formula to then talk about how the complement rules of probability, how we get that. So the probability that an event E will not occur is equal to 1 minus the probability that it will occur. So this is a very important piece right here, okay? We simply take 1 minus the probability of an event occurring, and vice versa. If I wanted to know the probability of an event occurring, but I know the probability of it not occurring, I could use this formula here, okay? All right, so we're gonna look at if you were to use set notation. Notice this E kind of prime, that's called the complement, that's just the notation. So you could say the probability of the complement of E equals 1 minus the probability of that event E happening, or vice versa. The probability of that event is 1 minus the probability of its complement. All right, so really the two most important things right now are these guys right here. Okay, so let's look at this first checkpoint. So you are dealt one card from a standard 52 deck. Find the probability that you are not dealt a diamond. Okay, so what I could do is I could say, oh, well, what's the probability of pulling a diamond, right? Remember, there's 13 diamonds in a total deck, so 13 out of 42. That's our probability that we will pull a diamond. So then what's the probability of not getting a diamond? I'm simply going to subtract 1/4 from 1. So 1 minus 1/4, and that's where we get 3/4 from. So what I want you to do is I want you to take a look at checkpoint 2. Look at the table of values, look at the diagram, the graph that's next to it, and determine the two parts. What's the probability of not pulling someone from the age group of 50 to 59, or at least someone that's 20 years old? So take a look, pause the video, and check back. A very important piece before you begin is to recognize what's the total number of people being polled, all right? The number of U.S. car drivers by age group. So if you add up all these guys, 9 million, 33, 40, another 40, 31, 19, 13, and 6, it should add up to 191 million people total, or drivers total. So with that in mind, go ahead and try parts A and B. So for part A, we wanted to find the probability, and it does say expressed as a simplified fraction, all right, that the person is not in the 50 to 59 age group. Well, in this case, it's probably easier to see how many people are in that age group. So if I want to know the probability of not being in that age group, I'm going to take 1, and I'm going to subtract the probability of being in that actual age group. Okay, so the probability of being in this age group from 50 to 59, if you look at the chart, is 31 million out of 191 million total. So the probability of not being in that age group is simply 1 minus that 31 over 191, And when you get your answer, you should get 160 over 191. So now part B. What's the probability that the person is at least 20 years old? So which age group could you look at, right? So what I did here was I looked at the age group of less than or equal to 19, age 19. All right, and then I could find the likelihood of being at least 20 by simply taking that probability of less than or equal to 19 and subtracting it from 1. So if we do that, I get 1 minus 9 over 191, and we get 182 over 191, and that doesn't simplify any. So again, we're just looking at this chart over here, okay, to get all of this information. So the 50 to 59-year-olds, that's right here in this orange pie piece, and the less than or equal to 19, that's in this small kind of pinkish reddish pie piece. We're going to stop here for this 11.6 notes for this video. We will finish these off in the next video, so check back. Welcome to video 13. This is the second part of the 11.6 notes. So we're just continuing on with what the last video started. So now we're going to talk about the probability of one event or a second event occurring. So we need to understand the term mutually exclusive. So what does it mean to be mutually exclusive? It's when it is impossible, all right, that's key, impossible for events A and B to occur simultaneously or at the same time. So this is dealing with an OR probability with mutually exclusive events, all right? So if A and B are mutually exclusive events, then the probability of A or B happening is going to be the probability of A plus the probability of B. So here's our set notation. Again, that just means OR, so we can split it up. Okay, so if we look at this checkpoint 3, if you roll a single 6-sided die, what is the probability of getting either a 4 or a 5? So these cannot occur at the same time when you roll a die. Sorry about the bell. So these, again, can't occur at the same time. I either roll a 4, a 5, or I don't roll a 4 or a 5 or roll something else. So we can say this is the probability, this is mutually exclusive. So I want to know what's the probability of rolling a 4 plus the probability of rolling a 5. So rolling a 4 is 1 out of 6. Rolling a 5 is also 1 out of 6. When we add those together, we get 2 out of 6. But of course, we always simplify. So our final answer here is 1 out of 3 chance, or 1 out of 3 probability. Okay, so then our next thing that we need to talk about is, well, what happens if they are not mutually exclusive? So we're going to look at OR probabilities with events that are not mutually exclusive, meaning that they can occur at the same time. So if A and B are not mutually exclusive events, then our probability is going to look just a little different. So if I want to know the probability of A or B, I'm still going to take the probability of A, add that to the probability of B, but then I'm going to subtract the probability of A and B. So the probability that they're both occurring at the same time. Again, here's your set notation. I'm not going to worry too much about that right now. So let's take a look at this with our checkpoint number 4. All right. So in a group of 50 students, 23 take math, 11 take psychology, and 7 take both math and psychology. Okay? So if one student is selected at random, find the probability that the student takes math or psychology. All right, so if we take a look, here's the probability of just taking math. 11 people out of 50 taking psychology, but then we have this overlap. 7 people take both math and psychology. So what's this going to look like with our setup? Well, let's take a look. So I want to know the probability of taking math, and we're going to add that to the probability of taking psychology, but then we have to take or subtract the probability of both of these events occurring at the same time. So the probability of math is 23 out of 50, plus the probability of psychology is 11 out of 50, and then we're going to subtract the overlap, which is 7 out of 50. So when we combine these, since they all have the same denominator, we can just combine the numerators. So 23 plus 11 minus 7 gives us a grand total of 27 out of 50. So that's the probability of taking math or psychology, not both. Okay, I want you to try checkpoint number 5 on your own. Take a look at the spinner, figure out what you need to do, set it up, and attempt it, and then check back. So we want to know, using the spinner, to find the probability that the pointer will stop on an odd number or a number less than 5. So I want the probability of odd or less than 5. So in order to break it up, because these are not mutually exclusive, they can happen at the same time, I need to find the probability of being an odd number, the probability of being less than 5, and then the probability of being odd and less than 5. So if we take a look at this spinner over to the right, and I'll kind of show my work along with it, the probability of being odd is 4 out of total 8 numbers. So we have 1, 3, 5, and 7 are my odds. The probability of being less than 5, well, the numbers that are less than 5 are 1, 2, 3, and 4, so 4 out of 8. And what's the probability of being odd and less than 5? Well, that's just 2 out of 8, numbers 1 and 3. So what's the what's the probability that my spinner will land on an odd number and that's less than 5? Well, now we go ahead and, less than 5. I take 4 plus 4 minus 2, since my denominators are all the same. We get 6 out of 8, and of course we're going to simplify that to 3 out of 4. Checkpoint 6 is very similar. We're just looking at a table rather than a pie graph or given some information. So if one person is randomly selected from the population, find the probability of the following. Express probabilities as simplified fractions and as decimals rounded to the nearest hundredth. So it's good getting practice here. All right, so the first one is we want to know what's the probability that the person is married or female. So these are not mutually exclusive, meaning I could be married and a female at the same time. All right, so kind of keep that in mind. It does help to note what the total population is, so 242, okay? So I want you to take a second and get your setup, and then we'll check back. Okay, so what I did was I found the probability of those that were married, plus the probability of being a female, and then I subtracted the married and female. So the probability of being married was 130 out of 242, looking at our table. The probability of being a female is 124 out of 242. And then I had to subtract the females that were married. So 65 out of 242. Okay? So then we can go ahead, add 130 plus 124, subtract 65, and we get a total of 189 over 242. That's as simplified as it gets, but then if we were to plug that into our calculator and round to the nearest hundredth, that's 2 decimals, we would get 0.78. Okay, what about part B? The probability of the person is divorced or widowed. Now, one thing you should note is these events are mutually exclusive. They can occur at the same time. They can occur, or they cannot occur at the same time. They cannot occur at the same time. So these are mutually exclusive. And one way I can look at and see is that I don't have a row where I have someone that is divorced and also widowed. The divorced is a column and the widowed is a column. There's no overlap though there. So I can say these are mutually exclusive. So if they're mutually exclusive, we're going to take the probability of being divorced, add that to the probability of being widowed, and we're going to get our answer. So 24 out of 242 are divorced. Being widowed, I get 14 out of 242. Adding those together, 38 out of 242, which is simplified to 19 over 121. Plugging that into the calculator, we get 0.16. The next thing we're going to talk about in 11.6 is probability to odds. So we're going to talk about odds right now. So probability to odds. If the probability of event is the probability of an event E occurring, then we've got two scenarios. All right. The odds in favor of E are found by taking the probability of E over the probability of the complement of E, or the probability that E will not occur. Okay? Then we can look at, well, the odds against. So odds against some event E occurring is just going to be the reciprocal. So the odds against are going to be P of not E over P of E. Okay, so we need to keep those straight. So in favor is the probability of that event over the probability of the event not happening. And then the odds against are the probability of the event not happening over the probability of the event. So the odds against E can also be found by reversing the ratio, representing the odds in favor of E. So that just means take the reciprocal. Just switch those guys around, the numerator and the denominator. So let's take a look at this first example. Okay, so we are dealt one card from a 52 card deck. All right, so what we want to know is we want to know the odds in favor, okay, of getting a red queen. So the odds in favor of getting a red queen, meaning I'm looking up here, odds in favor. So I want the probability of getting a red queen over the probability of not getting a red queen. So thinking about a deck, there are 2 red queens out of 52. So what's the probability of not getting a red queen? Well, that means there's 50 out of 52 that are not red queens. So now when we clean this up, and one thing we can do, if you're not quite sure how I got to that next answer here, is if I multiply both the numerator and the denominator by 52, these guys cancel, and that's why we're left with 2 over 50. Which simplifies to 1 over 25. And then you could just read this as 1 to 25, or it's read as 1 to 25. If you've ever seen, or if you've ever gone to Arlington Racecourse and watched the horses race, you would see the odds up on the board prior to the race. Okay, the next one says find the odds against getting a red queen. So how's that going to change what we found in A? Pause the video, give it a shot, and see what you get. Hopefully you realized all we have to do is switch our numerator and denominator. So now I want to know the probability of not getting a red queen over the probability of getting a red queen. So again, this was the odds against. We have to read very carefully. So when we clean everything up, this time we get 50 over 2, or 25 over 1, or we could read it as 25 to 1. Again, you could write it as 25 to 1 against getting a red queen. Okay, read through checkpoint 8, where it says the winner of a raffle will receive a 2-year scholarship to the college of his or her choice. If 1,000 raffle tickets were sold, and you purchased 5 tickets, what are the odds against your winning the scholarship? Try your setup, check back in a second when you've got a chance. Since it said odds against, my setup is going to be what's the probability of not winning over the probability of winning. So maybe it's easier to figure out the probability of winning first. I bought 5 tickets out of 1,000 tickets that were sold. All right, so what's the probability of not winning? Well, if we're thinking about that, the probability of not winning is going to be 995 tickets out of 1,000. So our setup is going to be 995 over 1,000, all over 5 over 1,000. The thousands will essentially cancel, and as we continue cleaning up, we get 995 to 5, or 199 to 1. So the way we would read this is there's 199 to 1 that you won't win. So odds enable us to play and bet fairly on games. Using odds in a gaming situation where money is waged, we can determine if the game is fair. If the odds in favor of an event E are A to B, the game is fair if a bet of A dollars is lost if event E does not occur, but a win of B dollars, as well as returning the bet of A dollars, is realized if event E does occur. So again, it kind of goes back to that horse racing that I talked about. So this is going to lead us into odds of a probability, or so odds to probability, all right? If the odds in favor of event E are A to B, then the probability of the event is given by, so the probability of the event here is given by this formula, A over A plus B. So if the odds in favor of the event are A to B, then we can go ahead and use the probability that that event will occur, okay? So we can take those odds and replace it with a probability formula. That's what it's saying. So this last checkpoint here says the odds against, so that's kind of, remember, we got to read carefully. So odds against a particular horse winning a race are 15 to 1. Find the odds in favor of the horse winning the race and the probability of the horse winning the race. Okay, so if those are the odds against, then we can kind of think about this 15 to 1 as our B to A. Okay, so if we wanted to talk about the odds in favor, we just have to switch that. So the odds in favor are simply going to be 1 to 15. Okay? So now we're just going to use this formula to help figure out the probability. So if I know what A and B are, I'm just going to plug that in here. Okay? So the probability of the horse winning is simply going to be, using our formula, A over A plus B. A is our 1, so 1 over A plus B, B is 15, and we get 1 to 16 is the probability, or 1 out of 16 chances is the probability of our horse winning, with the odds against it being 15 to 1. If you have questions on this video, make sure you ask them next time we see each other.